Let's take a look at question 8.3. Given that y equals 4x minus 14 is a common tangent to f of x equals 2x squared minus 4x minus 6, and g of x, which is equal to ax squared plus bx minus 18, calculate the values of a and b. Now, the first thing I want to do is I want to work out the coordinate where the tangent touches f of x. So to do that, I'm going to start by first calculating f prime x. So f prime x is going to equal 4x minus 4. Now remember that this f prime x, this derivative, is the gradient of the tangent. And we know the gradient of the tangent because they've given us the equation. The gradient is 4. So we can equate this to 4. So 4 is equal to 4x minus 4. 8 is equal to 4x. And so x is equal to 2. Now to work out the coordinate, we need the y value. And to get the y value, I'm going to take this x value and substitute it into the easier equation, which is going to be the tangent equation. So y is equal to 4 times 2 minus 14. Y is equal to negative 6. And this is an important point. So 2 and negative 6. Now that we have the point, we can then start with the g of x formula and then try to figure out the values for a and b. Now with g of x, the first thing I want to do is I want to substitute this coordinate in, since it's going to be, since it's a tangent to both of them, that point should lie on g of x. So I'm going to substitute this value in, or this coordinate in. So negative 6 is equal to a times 2 squared plus b times 2 minus 18. Negative 6 is equal to 4a plus 2b minus 18. We can then transpose or take the negative 18 over. So 12 is equal to 4a plus 2b. Now you'll notice we have two unknowns, a and b, and so we will probably need another equation to solve simultaneously. Now what we can do is we can do the same thing that we've done to f of x, which is take the derivative. So the derivative of g of x, so g prime x, is going to be 2ax plus b. And recall that's going to be the gradient of the tangent. And we know the gradient of the tangent is 4. So 4 is equal to 2a. And we know the x value again. So 2 plus b. Let's simplify. 4 is equal to 4a plus b. And so we have our two equations. Now to solve for a and b, there's obviously you have the elimination method or the substitution method. I'm going to use the elimination. So I'm going to write down equation 1, 4a plus 2b equals 12. And then the second one is going to be 4a plus b is equal to 4. Now I want to cancel out the 4a's, so I'm going to turn this to a negative, that to a negative, and that to a negative. So 4a minus 4a is 0. 2b minus b is b. And that's equal to 12 minus 4, which is 8. So b is equal to 8. Then to work out the a value, substitute it into either one, equation 1 or 2. I'm going to substitute it into equation 2 just because it's more simpler. So 4 is equal to 4 times 8 plus b. So 4 is equal to, this is going to be a and this is going to be 8. So 4a plus 8, take the 8 over, minus 4 is equal to 4a. A is equal to negative 1. And so we have our values for a and b. Let's take a look at question 9. Given f of x is equal to x cubed minus 6x squared plus 9x minus 4, and it can be rewritten as x minus 4 and then x minus k all squared. Question 9.1 show that k is equal to 1, and that's worth 2 marks. Now, there's actually a number of ways that you can do it. Though for 2 marks, I think that the easiest way would be simply to use a factor theorem. A factor theorem says that if you substitute an x value in and the output is 0, it means that that value that you substituted is a factor. So let's substitute into our equation. So we'll sub x equal 1. That means y is equal to 1 cubed minus 6 times 1 plus 9 times 1 minus 4. 1 minus 6 plus 9 minus 4. That's going to give you 5. That's going to give you minus 5, and that's 0. So since the output is 0, it means that 1 is a factor. And so since we have the equation already written, x minus 4, it means that k must be 1. Okay, question 9.2. Calculate the coordinates of the turning point of f. Now, to calculate the turning point for a cubic function, you take derivative of the cubic function and you equate it to 0. So f prime x is equal to 0. So the derivative is going to be 3x squared minus 12x plus 9. That's equal to 0. We can divide everything throughout by 3. So x squared minus 4x plus 3 is equal to 0. Now factorize x minus 3. Then x minus 1 is equal to 0. X is equal to 3. Or x is equal to 1. And so this is maybe an alternative way that you could have shown that k is 1 because you have a turning point. Now remember, they want coordinates, so that means they want y values as well. So to solve for y values, you take the x value and substitute it into the original equation. So if I substitute x is 3 into the original equation, I'm going to get negative 4. Or if I substitute 1 into the equation, I'm going to get 0. Right? And we did this in the previous question, so we know that it's going to be 0. So that we know the coordinates are now going to be 3 and negative 4 and 1 and 0. So these are my turning points. Moving on now to question 9.3. Describe the concavity of f at x equal negative 3. So concavity, we need to take the double derivative. So the double derivative is going to equal, what was our word? So it's going to be 6x minus 12. 6x minus 12. And now they want to know at the point minus 3. So 6 times minus 3 minus 12, and that's minus 30. Since the double derivative is less than 0, we can say that it is concave down. If it was greater, it would be concave up. Question 9.4 says sketch the graph. So to sketch the graph, remember we've been working out the points all along, so we just need to use them. So you have your x-axis, you have your y-axis. We solved our turning points. Our turning points was 3 and negative 4 and 1 and 0. So 1 is here, 3 is here, negative 4 is somewhere around here. So that's one turning point, that's another turning point. The y-intercept, you solve when x is 0. So my y-intercept will be negative 4. And then to solve for the x-intercept, y should be 0. And so if we have our equation 0 is equal to x minus 4 and then x minus 1 all squared, we know that x will equal 1 or x will equal 4. We've got one of them already, but the other one will be here. So 4 and 0 will be our next point. And now we can kind of figure out or kind of see the shape that it's going to take. So it will take a shape like this. Just imagine that it's cutting it at negative 4. And that's the shape. Okay, let's move on to question number 9.5. Calculate the maximum vertical distance between F and H, and the x value should be between 1 and 3. if h of x is equal to minus 2 multiplied by f of x. So let's work out what h of x is first. So negative 2, and then f of x was 3x squared minus 12x plus 9. That means h of x is going to be minus 6x squared plus 24x minus 18. Now remember, to get the vertical distance, let's call that d, it's going to equal f of x minus h of x. So you subtract the two. So f of x is x cubed minus 6x squared plus 9x minus 4. And we are subtracting minus 6x squared plus 24x minus 18. We then open up the bracket and solve. We're going to get x cubed minus 15x plus 14. So this is the equation that represents the height or the vertical distance. Now to get the maximum distance, we need to take the derivative of this. So the derivative is going to equal 3x squared minus 15. And we equate that to 0 to get the maximum. So now we can simplify. That's going to be x squared minus 5 is equal to 0. That means x is going to equal plus minus the square root of 5. So that's going to be 2,24 or minus 2,24. But since we were restricted, we said the restriction was x needs to be between 1 and 3. We're only going to consider this value. And now to calculate distance, you take this value and substitute it into our distance formula. So the distance is then going to be 2,24 cubed minus 15 into 2,24 plus 14. And that gives us a distance of minus 8,36. So we'll take the positive value. So the distance is 8,36 units. And that's it. Thanks so much for watching. I hope you found this useful. Don't forget to like, share, and subscribe. I'll see you all in the next video. Bye.